Okay, on the other side, we have to redraw the cross section using now a scale of 1 to 100. And the whole point of this, having them alongside each other, is so that I can show you the difference between the exaggeration of 1 to 20 centimeters, or 1 to 20 meters, and 1 to 100 meters. So again, we can use our same rough sketch. That doesn't change anything, except that we're only going to be marking off the 100-meter intervals. We're going to prepare our y-axis. Yours is actually split on your paper. And so we know that our cross-section goes from 1,000, our highest height will be, what we can see in terms of 100 meters will be 1/400. And so we go one up from that, which would be 1/500. And then our lowest height goes all the way down to 1/200. And so we're going to go down to 1,100. So this is our range. I'm going to prepare this side of the cross section and just use a darker Koki so that you can see the line a little bit more easily, because mine's not split. Okay. And then starting at 1,100 for my first interval on the y-axis, then 1,200, you can see 1 centimeter represents 100 meters, 1,300, these are the easiest to do because they're so quick, 1,400, and lastly 1,500. Then we're going to place our rough sheet against the actual axis so that we can plot our points. Again, you can show your starting point is in line with the actual y-axis. Your ending point we mark on that x-axis. Keeping the starting point aligned with the y-axis, we're going to go to our first point, which is 1,400, and mark that off. Then 1,300, because we are only doing the actual 100-meter intervals, 1,200. And if you're running out of time, this is a little tip for you in an exam. If you're running out of time and you've been asked to do a 1 to 20 meter, and you don't have time for all the little lines, do a 1 to 100, because you're still going to get marks for the general shape and all the labels and things that you need. You might maybe only lose 1 or 2 marks, 3 marks, depending on the mark allocation. All right, so that was 1,200. We're then going to jump across and we're going to go to our next 100 interval, and that specifically was this one over here, 1,200. So you can see that it's a fairly flat gradient between those two. And then the last jump is 1,288, and we know that that actual trig beacon would have to then be represented between 1,300 or 1,200 and 1,300. So it's slightly below the 1,200 mark, so that we can indicate 1,280. We end off our cross section. Now this obviously being quite an easy one, and then also remember your spot height was 1,412. And so if it was 1,412, it really, between 400 and 500, each of those obviously represent 20. So it's going to be right there, just below the first line. And we're going to join these features up, showing the relatively flat nature of the floodplain going up towards the trig beacon. You can end off your cross section. You can see that it's obviously not as exaggerated as the one that we already did. Okay, and again, label all those various features. So again, you can mark off where does the river hit your actual image. And so I keep it aligned with the y-axis, and there I can see that is where my river intersects my cross section. Then I have the N4. Okay, I've got the railway slightly higher, and this is really showing you a little bit more of a realistic shape, and because it's not as exaggerated. And then the hiking trail that was very close to it. Okay. And then our slopes, you can actually see quite easily here that this is a typical convex slope. And that this is a typical concave shape. Again, you're going to give a heading. It's the same heading as the other one, but what is different here is that this is now no longer 1 to 2,000. We need to work out what the vertical scale is. So on our rough piece of paper, we know that it said 1 centimeter must represent 100 meters. Again, you cannot put those both into the ratio. So we say 1, and then we need to actually say 100 times 100 to get that into the centimeters. And so it's 1 to 10,000. You can see there your 4 noughts. And so that is the vertical scale. So we're going to add that to the side here. 1 to 10,000 is the vertical scale. We still used a normal 1 to 50,000 topographical map, so that's the x-axis scale. And if we work out our vertical exaggeration, again we can use our formula and say vertical exaggeration is equal to the vertical scale over the horizontal. We know that our vertical scale is now 1 over 10,000. And that our horizontal is 1 over 50,000. If we convert those ratios out, we're dividing each of those. So we can then say that 1 over, I'm not going to miss any steps just because this is the example. We've already done the divide, so let's say times here, 50,000 over 1. And that obviously then means 50,000 divided by 10,000, which gives me 5. And you can see then that we've only exaggerated this diagram 5 times as opposed to 25 times. So at the bottom here, I'm going to say the vertical exaggeration is equal to 5 times. Now you can clearly see the difference between the two. On a scale of 1 to 20 meters, the exaggeration was 25 times. You can see how much more we've exaggerated the shape of our actual cross-section. But the exact same landform shown on a 1 to 100 is much less exaggerated. And in fact, it's only 5 times.